All right, so I wanted to give you guys something to help you through this, but this lab basically is going to be using this conversion highway. You're going to start at one of these places and have to go to another place, and it's in a lab setting. So for this first one, you have an aluminum can that's 11.309 grams. And so what you're going to want to do is take that 11.309 grams and convert it to moles, right? And so, whoops, moles. So we're trying to get to moles. And so to do that, if you look at that conversion highway, what you want to do is to get from grams to moles, you want to divide by what's on the periodic table. So we're going to want to divide by this number here, the 26.982, which hopefully you'll grant me is basically 27. So we want to divide by 27 grams, and that's for 1 mole. And that is how many moles you have in an aluminum can. So in that particular one, 11.309 divided by 27 is 0.418, 0.419. All of those are good. All right, so then moving on to the next can, and this one, same situation, moles. Now we have 14.524 grams. So we're given 14.524 grams. That's a good picture. And again, we're going to divide by the grams on the periodic table. So 27 grams in 1 mole. And that'll give us 14.524 divided by 27, 0.538. It's as good as anything. Moles. Oops, moles. There we go. Anyway, all right. This next one is water, which is H2O, and there's 56 grams. So since water is H2O, then we need our, since this is a compound, there's 2 atoms of hydrogen, each one weighs 1, right? And then there's, for the oxygen, 1 atom of oxygen, and each one weighs, we're going to call that 16. So that gives us a total of 18. And then same thing, since we're finding moles from grams, we're going to start with our grams and then divide by the 18 grams we just had, and that's 18 grams in 1 mole. And when we divide 56 by 18, we get, so there's 3.11 moles of water in 56 grams. All right. So now we're looking for the number of molecules. So to get to molecules, you can start with grams and do what we just did, get to moles. Or since we already know the moles, all we got to do is multiply by 6.02 times 10 to the 23rd. So the moles we got here, we just need, so the cylinder is teared. So yeah, we can get to molecules by just multiplying 6.02 times 10 to the 23rd times the moles we got. So I'm going to just go to a calculator. All right, and our moles was 3.11. So it's 3.11 times 6.02 times 10 to the 23rd. And we get 1.87 times 10 to the 24th. So that one is 1.87. And we can hit this for the times 10. And then you can use this thing to get to the 24th. You could put anything in there as well, like a caret or, however you want to do that. Or you can put 1.87 E24, like it's just here. You could just put this there. That's all fine for that answer. All right, number 5. So this one's kind of hard. The element nickel. So here's a nickel. It weighs 4.853 grams, but 45% of it is actually nickel. So the way you do that problem is 4.853 grams times 45%. So we were learning yesterday 45%, right, is 0.45. That's what we were learning yesterday. 45% would be 0.45 as a decimal. So we're going to multiply 4.853 times 0.45, and that's going to tell us how many grams, 2.18. So of that nickel, 2.18 grams, or almost half of it, is actually elemental nickel. And then the question is, how many moles is that? So if we have 2.18 grams and we've got to get to moles, we're going to need to divide by this number, right? I'm just curious. There it is. I was told I could have fireworks. It's not letting me have fireworks. All right. 58.693. So you divide this by 58.693, and that's for 1 mole. So 2.18 divided by 58.693 is 0.037. So the answer is there's 0.037 moles of nickel in 1 nickel. Anyway, all right. The next one is salt. You're trying to figure out how many moles of salt there are in salt. So there's 4.78 grams. Look, there it was. All right. 4.78 grams of NaCl. So now we got to do the thing with the number of atoms and the mass for NaCl. So for Na and Cl, there's 1 atom of each. For Na, it's 23.0 on the periodic table. Okay, so it's 22.999. So we're going to call that 23. And then for Cl, we're going to use 35.45. And then that's just going to be the same. And then we add that up. 58.45. So again, if we're trying to get to moles, we need to divide by what we got from the periodic table. This is what we got from the periodic table. And that gives us 0.082. So that's how many moles of salt there are in a teaspoon of salt. All right. And then how many pennies would be required to get a mole of copper? So each penny is 2.966 grams. So 1 penny, let's get into more of a penny color. All right, so 1 penny equals 2.966 grams. And in the old days, these pennies used to all be copper. So how many pennies are there for a mole? Well, copper, we would need 63.5 grams. This is what this is telling me, 63.5 grams. So how many pennies in 65.3 grams. So if 1 penny equals, this should look like to you a domino, right? This should be looking to you like a domino, and I have grams. So if we're going to do our little domino work, we have, ooh, ugly. Where's the eraser? Let's erase that. Pretend that didn't happen. All right, so if we have 65.3 grams, we're going to want the 2.966 in the bottom, and we want the 1 penny on the top. And that'll tell us how many pennies it takes to do this. Now, there's other ways to visualize this. This isn't the only way to do it, but if you get up to the point that it takes about 22 pennies to equal a mole, then you did good work. So 65.3 divided by 2.966 is 22.01. So basically 22 pennies will get you a mole. All right, I have to go to a meeting, so that's all I'm going to do right now, but I will release the next couple of questions on a video later today.